It's your boy Case today, and we're in MS Paint because we have to explain a complicated concept. So in Mario 64, there's this thing called graph nodes. Basically, you have a node, and this node has children. Let's say these are its children, and they all stand for something. So this might be the object node, and then the object has a child, which is, let's say, a part of his body, and then maybe this is another part of the body, this is another part of the body. So like if this is an arm, then right here might be like an elbow that is also a child of this, and they all point to their children. This points to the first child, and then each child points to the next child. The last child points back to the first child, and all of them point back. So this one points to its parent, this one points to its parent, and this one points to its parent, and they also all point to the previous. Right here, and of course this one points to the last previous, and as well as this one will point to its parent. So this makes sense. The reason we have this is so that we can insert new children. So if this is like an arm, a leg, and we notice, hey, we want to add another leg, we can just be like, oh, let's erase these two pointers here and store a new thing right here. This points forward and backwards, forwards and backwards. Very simple. But there's a problem with the system, and that is that we have way more pointers than we need. Because if we want to render the game, we need the first child pointer here, and then we need the next pointer and the next pointer and the next pointer, and then one more next pointer. And now we have all the pointers. We only need to read 4 of these pointers, well, and the child pointer here. So we only need a few of these. Around half of them are unnecessary. They do not do anything. So what do we do instead of this? Because the problem with having all of this is that when we render this object here, we're also caching the data for these 2 pointers and these 2 pointers. So we're caching 16 bytes of pointer data, when really all we would need is the child pointer and the next pointer. So actually we're caching way too much, way too much. 8 bytes on every node that we don't need. So instead of having the linked list here, I'll show you the new system. Let me delete all this. So the new system has a pointer here, a pointer here, a pointer here, and then somewhere else we have a table where it says, oh, this is 1 and this is 2 and this is 3 and this is 4, and then the table says, hey, 1 2 3 4, there's a pointer here and a pointer here, right? So this is then the parent pointer, this is the previous pointer, parent pointer, previous pointer, parent pointer, previous pointer. This is done in like a hash map, and this is still a forward linked list, a 2-dimensional one. This way, it's a little more expensive to add new nodes. But do we really need to add new nodes during gameplay? No, we just need to iterate our thing. And this saves, I think, around 8 microseconds over the entire frame when we render the object, which is very nice. Looking at the structure, you might think, hey, Case, this is stupid, this requires more RAM. Clearly, there's a reason not to do that. Well, that's not true, because we only need these hash maps when we're actually creating graph nodes, which is on level load, which is when we don't render. That's the key. Because now, if we really want to, we can just store this hash map over the Z buffer or the frame buffer, which means it will require 0 RAM, which means we have more RAM as well for the rest of the game. So this is faster, and this saves memory. It's amazing.